Hello, how are you? My name is Diana Araújo from Cefet of Rio de Janeiro, and I will present you the work entitled Robust Current Control of Three-Phase Grid-Connected Converters by Using the ADRC method. The presentation is organized as follows. In this talk, I will present you the work introduction, the system description and modeling, the control design and analysis, the simulation results, and finally, the conclusions. Voltage source converters, VSCs, have been an interesting option for several applications. Renewable energy sources, active power compensators, AC motor drives, among others. Control strategy is fundamental to establish performance requirements for equipments based on a static power converter. Current control approach plays an important role in the overall performance of the VSC. Several current control techniques for VSC system have been described in literature. Nonlinear flatness-based tracking control, multivariable PI-based control, and model predictive control. A traditional approach is often based on proportional integral PI feedback. This paper addresses the control design of a current mode control for a three-phase voltage source converter in DQ coordinates. The present proposal inner current loops based on the active disturbance rejection control ADRC method. Comparisons are carried out with the traditional PI. The proposed control scheme is based on two current components in the synchronous reference frame, SRF, IQ, and ID. Formulas: computation of reference currents and dynamic equation, linearized systems, control design and analysis, implementation PI controller, and the proposed ADRC strategy. In this slide, we define the simulation parameters of trial 1. In slide 8, we highlight the results of current regulation for both PI and ADRC controller, considering an inductance of 1.3 milliamperes. In this slide, we show the current regulation, but now considering an inductance of 0.65 milliamperes. In this slide, we have the implementation system of the simulation trial 2. in which the axis outer loop control DC voltage control. The D-axis outer loop regulates the DC voltage to its nominal value and creates the DX current reference, ID half of the inner loop. In this trial, the external PI controller gains KP 0.001 and KI 0.1 were given by reference Cadivarium. A capacitor 2.8 millifarads was inserted into the DC link. A staticon with a capacity of 4 MVA and power control was established for compensating reactive power. In this slide, we detect the reactive power steps for simulations, considering a system inductance of 1.3 millihenry. On the right, we have the results of current regulation for PI and ADRC controllers. In this slide, we have the time evolution of the DC link voltage for both PI and ADRC controllers. In this slide, we have the same reference reactive power steps, but now considering a system inductance of 0.65 millihenry. For this new trial, we have the plots of the time evolution of the DC link voltage for both PI and ADRC controllers. In this slide, we have the work conclusions. Analysis. In the current controlled two-level VSC system, ADRC controller is proposed in inner current loop controller. Initially, the operation of the VSC system was analyzed without the outer loop voltage controller. Later, with the DC voltage outer loop controller was included in the control strategy. The active power is now controlled by a DC link voltage control. The basic theoretical assumptions related to the designers of the ADRC controller and of the PI controller, both used in the inner current control loop. The simulation results show that the ADRC controller showed superior performance in the terms of robustness and fast dynamical response. It is verified that the use of the ADRC controller provide a more effective decoupling between the magnitudes of the DQ axis. For continuing the research, it is foreseen that the ADRC controller can also be applied in systems described in stationary reference frame. The authors would like to thank Cefet, FAPERJ, CAPES, and CNPq. Many thanks for their attention.